We're going to move on from solving equations and talk about solving inequalities. So instead of having a statement where two things are equal, we're going to have a statement where one thing is greater than or equal to or perhaps less than something else. So uh, let's look at one of the key differences here. If you have an equation like this, how many solutions? A solution is a statement that makes is a value for the variable that makes the statement true. So what is the value for this variable that makes the statement true? If x equals -5, then this statement is true. That's the only value that x could be that would make this statement true. So there's one solution to this equation. How many solutions are there to this equation? There's an infinite number of solutions. If x was 0, then this statement would be true. If x was -10, then this statement would not be true. If x was 10, then the statement would be true. And in fact, if we solve this by dividing by -2 on both sides and flipping this, which we'll talk about that in just a second, any x value that's greater than -5 will give you will make this a true statement. So if you plugged in 100 and you multiplied it by -2, that's a value that would be less than 10. -200 is less than 10. It makes the statement true. So with inequalities, you have many solutions, often infinite solutions. With equations, you usually only have a finite number of solutions. Okay, so here are some properties of inequalities. The formatting's a little bit messed up. I'm sorry about that, but let me just go. Yeah, there we go. So if I open to edit it, it looks fine, but these are really similar to with equations, but then you also have a few others, like the transitive property. If you have a value that's less than or equal to another value, so if a is less than b and b is less than c, then a is less than c. So if I said if 2 is less than 3 and 3 is less than 4, then 2 is less than 4. It makes sense if you plug numbers in. So you might want to pause and look at this. I'm going to highlight a few of the differences down here. Let me fill this in. Then a over c is, yeah, b over c, a over c, b over c. With multiplication, one of the biggest differences is that if you multiply both sides by a positive number, then the statement stays true and you don't have to change anything. But if you multiply them by a negative number, if you multiply both sides by a negative number, you need to flip that sign. So for example, if I said 2 is less than or equal to 3, if I multiplied both sides by a negative number, let's say like -10, then I would have -20 is less than or equal to -30. And that's not actually true. -20 is a bigger number than -30. It's closer to 0 than -30 is. So this isn't true. But if I flip it, then it's a true statement. So if I multiply or if I divide by a negative number, I need to flip these inequality signs. That's what those properties talk about. Alright, let's do some examples. Solve each inequality and then graph the solution. So I'm going to solve this very similarly to an equation. I'm going to treat this like the equation, the equal sign, and I'm going to try and get x by itself. So it's being subtracting 12, so let's add 12 to both sides, and you get 3x is less than 15. Divide by 3. Okay, we're dividing, so you need to be very careful. If you're dividing by a negative number, you flip this sign. If you're dividing by a positive, you don't. This is a positive number, so we don't flip the sign. And we get x is less than or equal to, just less than 5. X is less than 5 is the solution. So let's graph that solution on our number line. So let's say 0, 5, 10, 15, 20, -5, -10, -15, and it just keeps going forever on both sides. X is less than 5, so x is not equal to 5. It can't be 5. You signify that with an open circle, and then you draw an arrow that says all of this is a solution, all the way up to, but infinitely close to 5, but not 5. So if x was 4.99999, that's less than 5, and so that's true. But if x was exactly 5, is 5 less than 5? No, 5 equals 5, so it's not less than 5. But this is how you graph the solution. Alright, let's work on this other one. So we're going to do distributive property first. 6 plus 5 times 2 is 10. 5 times negative x is a negative 5x. Now let's combine like terms. 6 and 10 gives you 16. Let's get the x by itself, so subtract 16 from both sides. I'm going to write this over here, and now we have negative 5x is less than or equal to 41 minus 16 is going to give you a 25. Now we're going to divide by negative 5, and remember we're dividing, or if you multiply, if you do it by a negative number, you got to flip this sign. So let's go ahead and flip that sign now so we don't forget. Negative 5 over negative 5 leaves you with just x. 25 over negative 5 leaves you with negative 5. So the solution here is x is greater than or equal to negative 5. If you want to check your solution, pick a value for x, so like that makes this statement true. So like 10. 10 is greater than or equal to negative 5. And plug it back in over here, so in 2 minus 10 instead of 2 minus x, and see if that's actually less than 41. 6 plus 5 times negative 8, is that less than 41? 6 plus negative 40, it's definitely going to be less than 41. It's negative 34. Okay, so that's true. Alright, so now that we know it's true, let's graph our solution. X is greater than or equal to negative 5. So 0, negative 5, negative 10, negative 15, 5, 10, 15, 20. Okay, so negative 5 is where we want to be. We're going to do a closed circle because x can equal negative 5. Negative 5 is greater than or equal to negative 5 is a true statement, so we want a closed circle. And then we want the x values that are greater than that as solutions. So the x values over here make this equation true, make this statement true. Alright, example 2. Solve each inequality and graph the solution. Really similar. Alright, but it's slightly different, so don't just skip ahead. Okay, 2 times x and 2 times negative 5 gives you negative 10. Now let's get the x's by themselves. You subtract 2x from both sides, and this is what makes it different. Negative 3 is greater than negative 10. The x's are gone. Okay, we've simplified to something that doesn't have a variable in it. What do? Well, what it means is the solution to this equation does not depend on a variable. The variable is always going to cancel out no matter what x is. So you look at this statement right here and you say, is this true? Is negative 3 greater than negative 10? And the answer is yes. Negative 3 is a bigger number than negative 10. It's closer to 0 than negative 10. It's a more positive number. It's farther to the right on a number line. So it's true. So the solution is all real numbers. Okay? Any number that you plug in for x, they're going to cancel out like they did here, and you'll be left with negative 3 is greater than negative 10, which is true. So any number that you plug in for x will give you a true statement. So all numbers, all real numbers, are solutions. They're values for x that you could plug in that would make this a true statement. Now let's look at this one. 7x plus 6 is less than 7x minus 28. Again, you subtract 7x from both sides, and the x's are gone. And now we're left with 6 is less than negative 28. Another statement that doesn't depend on x. And this is not true. This is not true. So what we have here is no matter what value we plug in for x, we're going to get a statement that is not true. So there is no solution. There's no value that we can plug in for x that will give us a true statement. So that's no solution. So if the x's go away, it's either all real numbers or no solution, depending on if the statement is true. Okay, example 3. A band agrees to play for $200 plus 25% of the ticket sales. Find the ticket sales needed for the band to receive at least $500. So we need to write an equation for this. Go ahead and pause the video and try and do that. The equation that you would write is they're going to get $200 no matter what. And then they're going to get 25%, which you can write as a decimal as 0.25, times the ticket sales. And this is going to represent how much money they get. If we want to know what this has to be, t, in order for them to get at least $500, Okay, so you don't care if this is a way bigger number. If they made $1,000, $10,000, they're happy with that. But it has to be at least $500. So let's solve this inequality. Subtract 200 from both sides, and you get 0.25t is greater than or equal to 300. We're about to divide by something. We're going to divide by 0.25. So you got to be careful. Is this a positive or a negative number? It's positive in this case, so our sign is going to stay the same. It cancels out over here. 300 divided by 0.25 is the same thing as 300 times 4. And the reason why I know that is because 0.25 is the same thing as 1/4. So if you divide by 1/4, that's the same thing as multiplying by its reciprocal, 300 times 4. So they would need to sell, that was a terrible boxing job. They would need to sell at least 1,200 tickets in order to receive at minimum $500. So this is the solution to that question. Example 4 is going to talk about a compound inequality. So let's talk about what that is. A compound inequality uses the words and or. So an example of that is if I said the number 5 is less than 10 and, so there's the and it's greater than 1. Okay, this is a compound inequality statement. We're going to do it with variables. So I would say like x needs to be less than 5 and greater than 1. So the solutions there would be like 2, 3, 4, 2.273. Any value for x that is between 1 and 5 is a good solution there. Or means only one of the things has to be true. So and means both needs to be true. Or means one or the other. So x needs to be greater than 3 or x needs to be less than -1. You can see that and wouldn't work here at all. There's no number that's bigger than 3 and smaller than 1, but there's a lot of solutions where or works. You could pick if I said 5, is 5 a solution? Yes, 5 is greater than 3, so it works. Is -5 a solution? Yes, 5 is less than -5 is less than -1, so it satisfies this part, so it works. It's a solution to this or statement. So only one has to be true when it's or. Or is a little bit more tricky. What if I said x is less than 5 or x is greater than 1? Well, what this means is only one of these has to be satisfied. So let me draw the picture of this. Here's 5, here's 1. That's the solution. And these are the solutions. So since only one of these has to be met at any given time, any value that I pick for x is going to work here. If I said 10, 10 is greater than 1, so it works, because it's just or, it only has to be 1. If I said -3, -3 is less than 5, so it works. If I said 2, 2 works for either of them, so it works. So or means only one of these has to be met, and means both of them have to be met. Alright, let's go ahead and graph some of these. Graph the solution of 3x minus 1 is greater than -28, and, so that means both these have to be true in order for it to be a solution. 2x plus 7 needs to be less than 19. So I drew this line here so that you can know you solve these separately. Solve them as completely separate problems. So add 1 to both sides. 3x needs to be greater than -27. Divide by 3. We're dividing by a positive number, so the sign stays the same. 27 divided by 3 gives you 9. So x needs to be greater than -9, and 2x plus 7 needs to be less than 19, which means 2x needs to be less than 12 if you subtract 7, and x needs to be less than 6. So these both have to be true. X needs to be greater than -9, and x needs to be less than 6. So let's call this 0, -3, -6, -9, 3, 6, 9, 12. Okay, so x needs to be less than 6. Oh, that's supposed to be an open circle, but it's hard to do with such a fat pen. Okay, open circle at 6, going this way, the x's that are less than that. And an open circle at -9 going this way. But since it has to be a solution to both of them, it's only these values, the things that are in between x and negative 9. And you can actually write this as one statement. You can say x has to be greater than negative 9 and less than 6. And then this is the graph of that solution. Let's do one with an or. So now only one of these has to be satisfied in order for it to be a solution, because it says or. So 4y minus 2 needs to be greater than or equal to 14. 4y needs to be greater than or equal to 16, if you add 2 to both sides. And y needs to be greater than or equal to 4. If you divide 4 on both sides, this is what you get. Or, so that this needs to be met, or 3y minus 4 needs to be less than or equal to negative 13. So 3y needs to be less than or equal to 9, negative 9, and y needs to be less than or equal to negative 3. So if either y is greater than or equal to 4 or y is less than negative 3, then we're satisfied. So 1, 2, 3, 4. Okay, so let's graph y is greater than or equal to 4. So that's a closed circle, and the y is greater than or equal to are over here. And then at negative 3, that's also a closed circle because we have the equal, and the y is less than. So this is a graph of the solution. All the y's bigger than 4 and less than negative 3 work. These are the only values, the things in between those, are the only values that are not solutions to this equation. To this statement. Alright, let's do a word problem. The ideal length of a bolt is 13.48 centimeters. The length can vary by at most 0.03 centimeters. A machinist finds one bolt that is 13.67 centimeters long, so he needs to cut something off so that the bolt can be used. So at first, this seems like a really easy problem. It's like, okay, well, the ideal length of a bolt is 13.48 centimeters. 13.48. It can be off by 0.03. So if we add 0.03, 13.51 is the biggest it can be and still work. So if you have 13.67, I wrote 16. If you have 13.67, you gotta figure out how much you need to cut off. You need to cut off 0.16 centimeters. And that's true. You do need to cut off 0.16 centimeters, but you can't cut off too much or the bolt won't work either. So you also need to find the minimum that the bolt can be. At minimum, the bolt can be 13.45 centimeters. So let's do 13.67 minus 13.45. Alright, so if you cut off, did I do that right? No, 22. Just kidding. Okay, so if you cut off more than 0.22 centimeters, you have a problem also. So the machinist actually has to cut off between 0.22 and 0.16 centimeters. Let's do that algebraically so that we can see. You have a bolt that is 13.67 centimeters long. You need to cut off some amount, but it has to be within some range. It can be within 13.48 plus 0.03 to 13.48 minus 0.03. If it's smaller than this, it's too small. If it's bigger than that, it's too big. So it has to satisfy this equation. We've already figured that this is 13.45. And we figured out that this is 13.51. So now if you solve this compound inequality, you'll have the x values that work. So if you have an and statement, which this is an and statement because it's all written in one statement. Okay, so it's saying this and this both have to be true in order for this to work. So you can work it all out at once. You can do minus 13.67. Okay, you subtract the same thing from each part of these two inequalities. And here you get negative 0.22. And here you get negative 0.16. Oops, sorry. Like that. Now multiply everything by negative 1. Positive 0.22. You got to flip the signs. Flip the sign. And so you get an X value that's between 0.22 and 0.16 centimeters. If you cut off between that amount, then you're good and you have a bolt that will work.